Okay, it tells us this is the graph of G, but it also tells us that's a derivative of F. So I jotted down for myself, this is the F prime graph. And then when you want to go get your F function, you're going to have to integrate the F prime to get your F function there. When it tells us F of 1 equals 3, this is to me like an initial position problem. It'll tell me like, hey, at 1 second, we're at 3, and I want to figure out where I'm going to go at -5. So I'm going to start with my initial position is at 3. That's where I'm at 1 second. So I'm going to pick it up where I left off, and I'm going to integrate that to where I want to go. So when I integrate the F prime, that's going to give me F. Again, start with your initial position right there. That's where you're at after 1 second. So start at where you left off at the 1 second, integrate it to where you want to go. And now this is the integral of this graph in between 1 and -5. So when it's not left or right, you got to switch it, make it from -5 to 1. And when you switch it, it changes that symbol right there. And then you're going to do the area between -5 and 1. So in between -5 and -2, I did that first. That was just a rectangle 3 by 3, which gave us 9. Then I had this little sliver of a triangle here, which is 1/2 base times height. So that was 9 plus the 3 over 2. That gave me like 21 over 2. But since that all was below the x-axis, that integral was a negative number. And then you're going to a +1 though. So you got to do this little sliver of a triangle as well. Remember, it's between the curve and the x-axis, curve and the x-axis. Don't go over here, nothing. It's between the curve and the x-axis. So that's when I added in that other little area of a triangle. So -21 over 2 plus 1 over 2 gave, plus the 1 gave me 2 over 2, gave me -19 over 2 for that part. But then it's 3 minus the -19 over 2 to get this 25 over 2 number right there. So no calc on this one. Be careful with that arithmetic there. Practice that area, integral is area, and then make sure you study that beginning problem there where you're doing that initial thing and then integrating that derivative. Letter B, you're integrating between 1 and 6 of this function. So in between 1 and 6, so in between 1 and 3 is easy because that's just a rectangle. But in between 3 and 6, that's a curve. So I can't know what the areas are just by doing basic geometry, which is why they gave us what the g of x was equal to in between 3 and 6. So one of these, we're going to use basic geometry. The other part, we're going to do a basic integral and use the actual function, right? So when I integrate between the 1 and the 3, that's just the area of that rectangle right there, which is 2 by 2, which is 4. When I integrate between 3 and 6, I do a straight up integral right there. I integrate that thing. So go like to the cubed over 3, and then plug in the 6, plug in the 3, just practice on your own. Be careful with your arithmetic there. And then I got the 4 plus the 6 to give me a +10 for that answer. Letter C says, where is F both increasing and concave up? I know F is increasing where the first derivative is positive. And since F prime and G are the same thing, that's where that G graph is positive. And since this is my G graph, this is my F prime graph, if I want to know where that graph is positive, that means where is that given graph above the x-axis. So I just kind of box that for myself. And then it says, where is F concave up? I know F is concave up where the second derivative is positive. And if G is the integral of F, they told us that G is the derivative of F. G is the derivative of F, which means G prime is equal to F double prime. So if I want to know where is F double prime positive, that's the same thing as knowing where G prime is positive. This is the graph of G. So if I want to know where the G prime is positive, that's where the slope of that G graph is positive. So that's where that given graph is increasing going uphill. So I like to box my two items that I'm looking for, and I'm going to pick out my answer. I'm going to say, hey, where is it both going uphill and at the same time above the x-axis? That's right there in between 0 and 1, and that's right there in between 4 and 6. Now, before you go all the way to infinity, it just says the problem exists in between -5 and 6. That's why I'm not shooting that off to infinity. So just in between 0 and 1 and 4 and 6 right there. And then the last part of that says find the exponent of each point of inflection. We know F has an inflection point where F double prime changes sign. And we talked about F double prime is G prime. So and then that G prime is the slope of that given G graph. And then so I want to know where the slope of that given G graph changes sign. That's the same thing as asking where does that given G graph change from increasing to decreasing or decreasing to increasing. That's it. All right. And so I know this is staying constant. You might be thinking, oh, it does something there. That doesn't count. Your slopes have to change sign. So you have to go from like a negative slope to a positive slope or a positive slope to a negative slope. That's what you're looking for right there. So here's a slope of 0, then it goes positive, and then a slope of 0, then it's positive, and then a slope of 0, and then goes negative. And then the only number is right here. You have negative slopes, and immediately after that, you have positive slopes. x equals 0 is your only point of inflection right there. And then I kind of mentioned our normal stuff that we have a bunch of these where that up double prime is changing sign, that's equivalent to the G prime changing sign, and then the G prime, that's like the slope of that G graph is changing sign right there, where that given graph is changing from increasing to decreasing or decreasing to increasing right there. So I think they try to throw a wrench at us by making part of that stuff horizontal, but it's got to go from like going uphill to downhill or downhill to uphill, and then we're good there. Farmhouse.